This is practice 1. In here, we are going to learn how to use multiple case structure to implement this logic. In here, we just get the two input from the user A and B, and then we have three LED lights. If A is greater than B, we turn on LED 1. If A and B are equal to each other, turn on LED 2. Otherwise, we turn on LED 3. And this stop button is just while loop that encompassing everything inside, so that we don't need to run continuously. So whenever you click the stop button, or the program just exits. First of all, we just make the two numerical control A and B, A and B, and then also we try to make a three LED depending on the AB conditions. And here this is LED 1, and just while you're pushing down the control button and just dragging, and so this is LED 2, and this is LED 3. Okay, then in the block diagram, let me just rearrange everything. LED 1 and LED 2, LED 3. So between these input and outputs, we want to implement our logic. So in here, let me just first create the case, okay, case structure. So this is true. But before we do that, let me just encompass everything using while loop. So I click the while loop and try to put everything, my program here. So in this program, after that, this is a loop control. So I move mouse cursor and then click the right button and create control. So then you can see this stop button, okay? So from now on, once you run it, then you just whatever you do that, if you click this one, your program exits. Okay, then let's create the case structure. So this is case structure. So I want to make one case structure outside here. So first of all, I want to compare A and B. So if A is greater than B, okay, so if I put the comparison icon here, so this is greater, so just click, and if A is connected to the top input connector, and this is B, so if A is greater than B, if that's true, okay, I just connect this one. If that's true, I need to make LED 1 turned on, right? So otherwise I have to put all the false. I just assign all the false in LED 2, LED 3. So my logic is something like I need to create constants, the Boolean constants. So go to the Boolean, and there's a constant, true constant. So I just drag this one here. So I just connect this one to LED 1, because if A is greater than B, I want to make LED 1 turned on, so I put the true, and then I put the false to assign the false to the LED 2 and also LED 3. But right now you cannot execute your program because this turner is still hollow. You have to assign something else for a false condition as well. Okay, then let's go to the false. If A is equal to B or A is smaller than B, that's all the false. but we separate between equal and lower A and B. So inside the false, we have to add another case structure. So this is structure, case structure, just to make another case structure like that. So right now, this false is, you just come to this false when A is not equal to greater than B. So it could be equal or maybe A is smaller than B. So at this time, go back to the comparison and then let's think about the equal conditions. If A and B is not, A is not greater than B, that's why you come to this false. But if A and B is equal, okay, so that's why you just tap the wire from A and tap the wire from the B. So A and B is equal, I need to make LED 2 turned on. So again, so go back to the Boolean control. So this is true. So I just connect this one to my LED 2 and then the false to all other LED. Okay? And this is false. And then if you go to the another condition, which is false, false outside, inside the false, that means A is smaller than B, right? Because we start compare A and B, we're just looking at whether A is greater than B. If this is not true, then you check whether A is equal to B. If this is not true, it's a false, which means A is smaller than B, which means I need to connect the true time constant into the LED 3 and all the false to the LED 2 and LED 1. Okay? Now all the exit turner became the solid. So now you can execute your program. So let's run. So because A and B are the same values, LED 2 is turned on. If A is greater than B, LED 1 is turned on. If B is greater than A, LED 3 is on. So then if you click the stop button, you exit your program. In practice 2, we make a VI that calculates the area of circle or rectangle using case structure. So in this example, there's a selector button. So you can use you can use this button to compute the area of circle or rectangle depending on these selections, and all the variable that we need are given here: radius, length, and width. So if you select the circle, then only the radius will be considered to compute the area of the circle, and if you select the rectangle, then the length and width will be considered to compute the rectangle size. So in this one, we just make one selector, which is a bulletin button. So you can choose vertical or horizontal toggle switch or slide switch. It's up to you. So let's try to make horizontal bulletin button. So make this one is a little bit larger. And which side is which one? So this is sometimes it's a little bit confusing which one is on, which one is off. So I think by default this is a false and this is on, which is true. This is off, this is false. So in this one, maybe you can double click anywhere on your front panel and add text. So I want to make false to this side as a circle, and then I want to make this side as a rectangle. So this is a true part. This circle, it should be false. Okay. from your button. In any case, we know that which one is false and true. And after that, let me make a numeric control to give the radius and width and height. Okay, then we're kind of ready to show the size, okay, the area. Then now we have to make the key structure. So this is key structure. So if our selector is there, so selector is true, so which means this is rectangle, then I want to compute the size, the area of the rectangle. So which means width and height should be multiplied and just connect the result to the area. So inside we have to add, this is numeric and multiply node. So I want to multiply these two numbers, this one, and connect this one to there, and then output goes to the area. And if this is false, that means user select circle, then you have to compute the area of the circle using this radius pi r square. So in here I just want to use multiply to compute the r square value. So this is multiply, and I just say multiplications, and I have to multiply this one to pi. So where I can find the pi, so click the search and just type the pi, and you can find the pi under map scientific constants. So you can, this is pi, so you can just drag the pi and then multiply, and then this one connected to the output. Okay, now let's try to run. So first rectangle, and then this is, let's say 2, height is 5, and radius 1. Then if you run, then this area of the rectangle, if you choose the circle and if you run it, then you know that the area of circle, the radius is 1. So depending on where you then you can either calculate either the area of radius circle and or the area of the rectangle. Practice 3 is similar to practice 2. Depending on the operation selector, we want to display different results. For example, in here, operation, you can choose either additions or subtraction by clicking this arrow button. Then, depending on the same inputs, your results are different. And before I show how we implement this one in the LabVIEW, let me introduce one interesting data formats called enum in the LabVIEW. So this operator, this selector, actually implemented using the enum data type. If you go to the front panel, and then if you click on the right button, you can see the control panel, and there's a ring and enum button here. So these are text ring and menu ring. So you can use text ring and menu ring to select different conditions depending on your program. And enum is just one of the way to control, to select options among many different options. So right now, as you see that the enum actually is an integer, it's kind of integer platform, but you can associate any text string with the integer number. So what does that mean? After you place the enum, click the right button and go to the property. and there you can edit the item here. So by default there's a 0 value, but if you just click the insert, you can associate any text with this 0 value. So for example, I want to associate the additions option with a 0 value. Then so now subtraction was associated with the 0 and additions was supposed to associate with number 1. So, and then click OK. Then as you see that in the enum button, you can see the two different options, so additions and subtractions. So now subtraction is a 0 and addition is 1. So using this one, you can connect this one to your case structure. So in the case structure, we've been using a case structure for true and false case. But if you connect this enum to this selector of case structure, this one, your conditions automatically change to additions and subtraction, because that's what we registered into this enum data format. Okay. So that's why if user select additions, you can make a program under this addition conditions, and if somebody select the subtraction, then you can just edit all the programming that are supposed to execute under the subtraction condition. Okay, now if you understand this concept, we just simply finish our practice 3. So this is A and this is a B. And then I want to add the outputs. So this output should be supposed to be outside of this case structure. Now this is addition. If somebody choose additions, the A and B should be added, and go to the numeric and add icon. Then A and B are all added, okay, and connected to output. If somebody select the subtraction, then you can just do the subtraction, but still tap the same variable A and B, and this is output. Now let's try to run this program. So now this is subtraction, so if you run, your output is -1. But if you choose addition and run, then this is added. So the enum is pretty useful and pretty handy things when you have your user select many different options. So you can still use the case structure. So your case structure is pretty flexible. You can actually tie true and false, but you can tie the enum to your case structure. This is practice 4. We are going to learn how to use shift register when using while loop. And our goal is to make a VI that makes LED flickering using shift register. So that means LED is on and off continuously until you just click the stop button. We can implement this one pretty easily with a while loop. So let's go to the program, and let's try to make a new VI. First of all, I want to put the LED here. So this is my LED that I want to turn on and off continuously. Then in order to turn on and off continuously, I have to keep changing the input variable, which on and true or false, right? So the idea is that how we can do that. So right now, first let's put the bring the while loop. So this is a while loop. So I just put this boolean LED inside the while loop, and whenever you make a while loop, you have to connect the loop control. So I just click the right button and then create control. Okay. So this is my control button. So unless I push this button, this is keep running. Then I have to change the variable that feed into this boolean 4 so that I can keep changing it. So the idea is that we just use the shift register. So shift register, in order to add shift register onto the while loop, you move your mouse cursor to one of the left edge or right edge. Move your mouse cursor and then click the right button, and there's add shift register here. Okay. So right now, so what does the shift register is? This while loop is keep running it. So whenever the new while loop executes this inside everything inside there, any value from this shift register is the value you have stored onto the right shift register at the previous while loop time. So right now I want to just connect the boolean. So when I begin this while loop, I want to connect, for example, let's say the false statements, for instance, to here, which means when you run this program, at the beginning the false actually pass through this shift register and goes to this LED. And so I just connect this one to there, and after that when I passing any variable to this on the right side shift register for the next loop of while loop, I have to change the status of the variable. I have to change the status of current variable. So for example, this is a false, so next loop it should be true. Otherwise the boolean, the LED doesn't flicker. So when I pass this one to the right side shift register, I want to change the boolean status. Okay. So if you look at this one in the boolean, there's a not node. So I just bring this not node, and then I just change the status, and then passing to on the right side, which means this becomes the false becomes a true, then true goes to the right shift register. So the next loop, the true will come out from the left shift register and then goes to this LED, and then this one also changed from true and false to go to the right shift register for the following loop. Okay, so now this is pretty simple logic to make LED on and off continuously. So if you run, now this is too fast because the while loop is just executing, just keep running so fast. So in order to see the flickering, in order to make the flickering more noticeable to our eyes, you have to actually put some weight inside this while loop. So in here we are going to use the timing function here. So there's a timing folder, and then this is a weight. So you bring this weight here. So whenever you execute everything for a single execution, you can just set how long each while loop will take. So I just create constants, for example, about 5 milliseconds. This is milliseconds, so half second. So this one loop will each loop will take 0.5 second. So when you run, now on and off is keep changing at every 0.5 second, because in the while loop waits 0.5 second and just go to next loop and so on. So as you change this kind of wait time, you can change the flickering frequency. This is practice 5. We are supposed to create a VI that adds from 1 to 10 using shift register inside the while loop and display the results. In this front panel, we only need the output, display output. So this is a result. So I want to compute, keep adding from 1 to 10 and just display output, then just exit the program. So in here we can use a while loop, we can use for loop, or we can use a while loop. We can use both, but because this one asks us to use the shift register, so let's use the while loop. Go to the structure, and this structure, there's a while loop there. So I want to just make one while loop, and I don't want to place the results inside the while loop, because after I display out the results, then I just exit the while loop, so we don't need to put this one inside the while loop. And outside of here, let's first add the shift register. So move your mouse cursor to the left edge on the while loop and click the right button and add shift register. And then whatever the value you connect to the exiting shift register will come out here for next loop. But we have to keep adding from 1 to 10. So initially, at the very first time, I want to just connect the zero value. So go to the numeric, and then let's say this is constant, so just put the 0. I want to just passing the 0 at the very first time. And after that, please take a look at this looping iteration. Okay, this is loop iterations. So whenever the while loop exits, kind of executing, kind of keeping looping, executing everything, this loop iteration is automatically increasing. So at very first time the I is 0, and the next time I will become 1, 2, and 3, 4. That's the way we know how many times a while loop has been repeating. So we are going to use those kind of looping iteration number. We are going to keep adding from 1 to 10, which means we have to repeat while loop 10 times at least. Then whenever you keep the while loop, you have to increase the number to add something, right? So in here we are going to use the loop iteration. So the idea is something like this one. So at the beginning, you just connect the 0 to one of the input for the add node, and then you just connect this one to another add node here, which means at the beginning a 0 comes in, and then this becomes a 0, and 0 plus the 0 is a 0, but I want to make I starting with number 1 instead of 0. So in that case, you can just add a 1. So this is just on this numeric, under numeric folder, there is a 1 increments. Okay. So if I just insert this one, 1 increment here, so and then connect this line, which means at the very first loop, this starts at 0, but this one, 1 is increased. So this blue line has the 1. So 0 plus 1, and that result goes to the next round. And second round, 1 came from the left shift register, and then this I becomes 1, but 1 is added, that's why this becomes 2. So 1 plus 2 goes to the next shift register. So 3 came out, then I becomes 2, but 1 is added, that's why this one becomes 3. So 3 times 3 is added and goes to another next round. So this is actually that's the way we can add from 1 to 10 just continuously. Okay. Then this is a while loop, so we have to exit this while loop. Okay. So then we have to think about when we want to exit the whole while loop. This is stop if true. So we have to keep looping this one until this line becomes 10, right? Because we want to add from 1 to 10. So after you add the last number into there, then we want to exit this while loop. So that's why you need a comparison here. So this is comparison, so this is greater than, maybe we can say greater or equal, then we can just put this one. And if this line, okay, becomes greater than equal than create constant 10, then I want to stop this while loop because I just want to keep adding from 1 to 10. So this is my logic. So let me try. If you run, then this one actually run 10 times, and then when this one exits, whatever the value that transferred to the exiting shift register goes to your results indicator, which is 55. This is practice 7. In this practice 7, we create the VI that shows how many times you clicked the button in real time. So let's say in the front panel you have one button, and then this stop is just the stop button for while loop. So unless you push this button, this program keep counting how many times you have clicked this OK button. So if you click this OK button 6 times, it shows 6 times until you push this kind of stop button. So we are going to use the while loop for this VI. So first of all, we have to create a button, right? So the button is like a Boolean types button. So this is OK button. So let me just add the one OK button. And then we have to create the numeric indicator, so how many times the user push the button, so the number of okay. Then after that we go to the case structure, while loop structure, and then this is a while loop. And then let's create the control. So this is our stop button, So we're going to keep running this program until we pushing the stop button. So we have to count how many times somebody just pushing this OK button. So whenever you pushing this button actually produce the true variable as an output. Okay. So the idea is that if this output is true, you just add 1 to your keep counting number. Okay. So that's the ideas. So in this one, so that's why in this one, let me just add the shift to register on the left side, and then go to click on the right button and add shift to register. So whenever you start this program, the number of the pushing times should be 0. So I want to connect the 0 at the beginning. So I try to find the constant number as a 0. So I just connect this one here. And after that, whenever somebody pushing the OK button, if this is true, then I want to add one. I want to add one here. Okay. And then this one is the result goes to the exiting shift to register for next round, and then it just keep waiting whether 1 is added or 0 is added depending on somebody pushing the button. So in this one I want to go to the case structure. This is true false case structure. So if this is true, then I want to add 1 to here, right? So in here I want to bring the numeric control, which is here. So I want to change this one is 1. Then I want to add this one to here. Otherwise, if this button is not pushed, then 0 will keep adding. 0 will be added. So I just create the constant and put it 0. Okay. So after that, I want to check the number of pushing times in real time. So we have to place this indicator inside the while loop in order to check in the real time. So I just tap this wire to there. Okay, so let's try to run and see whether this one works. Okay, this is on, so let me try to pushing one time. So I push 1, I push the another one, push. So whenever I run kind of pushing this button, this one is counting how many times I have pushed click this button, and just keep increasing, right? So this one seems works well. And what if you want to add another button? So instead of keeping increasing this pushing button, if you add another button, so that if you click the second button, you can make the total number kind of decreasing. You think about it, how you can make it. So you can just add another button, and then instead of add, and then you just subtract that number, right? This is assignments, and using while loop we create a VI that computes a factorization. So you just get the one number from the user. So let's say user input the 5, then code computes the results of 5 times 3, 4, 3, 2, 1, 2, 1. That's factorizations. If somebody just type 7, you have to, your program should compute the results of 7 times 6 times 5, 4, 3, 2, 1, so on. So in here we have to pushing the user input, so the number, okay. Then as you see that we want to just keep looping something until it just computes every the number. So whenever you loop the iterations, then the number should be decreasing by 1. So eventually it becomes 1, you end the while loop. That's pretty much the logic. So let me first get the while loop. So this is a while loop. And in the while loop, you have to always have to create the control for the while loop so that you can exit whenever you want. At this time, maybe because this is factorization machine, probably we don't need to this stop button. So let me just leave it open so we can later just exit automatically when your number is decreasing down to 1. Okay. Then after that, let's add a shift to register. Okay. So right now our first value we are going to multiply is whatever the number you input, right? So let's say this is 5, then 5 goes there, and the 5 times, 4 times, 3 times, and so on. So now you understand that we have to multiply something, so we have to add these multiplications here. Then we have to think about how can we decreasing the number. So at first time this one the 5 comes in here, and next time it comes to 4, it comes to 3 and 2, 1, and everything, and the result of multiplication goes to the right side. So we have to use this loop iteration. So I told you that in the while loop, whenever the while loop iterates, the loop control number will increasing from 0 to whatever the number. So my logic is that first, if we subtract our input with this loop window, loop number, then at the first iteration, this output from the subtraction node should be 5 because this is a 0. Okay? But next loop, this becomes 1. That's why if this one becomes 4. So in order to do that, maybe let me just bypass this while loop here. Let me bypass this while loop because we want to keep looking at the same value. Okay. So this is still like 5. So this 5 is subtracted by 0. This is 5. So this one should be multiply this number. Okay. And then instead of connecting the numeric into the left to shift to register, you have to add the initializing one is 1. Okay. I want to just passing the 1. So this 1 is multiplied by this one. So at the very beginning, 5 minus 0 is a 5. 5 times 1. So 5 times 1 goes to this exiting register. So next loop, the 5 comes out here from the left, and this I becomes 1. So 5 minus 1 becomes 4. That's why 4 times 5 goes to the next shift to register. Then just keep looping at it. So when you, so this is another exiting kind of conditions. So when you have to exit this one, I want to exit this while loop when this subtraction result becomes 1 or lower than 1, right? So we have to go to comparisons here and click this less or equal. So if this this number, okay, if this number is lower than or equal to creates constant 1, then that's the condition that I want to exit this while loop, like that. And then I have to display output, so numeric control and control indicator, this is output. So we don't need to check the output in the real time, so I want to place my output outside of while loop and then just connect this one to my output. Okay. Then let's try to run. So 5 times 2, 4 times 3 times 2, 1 is 120. Is it correct? Yes, it's correct. And how about if you change this one 3, 6, and 10? It's a huge number, right? So please pause and then think about this logic. So rather than you just copying pasting this program, you have to understand this logic, and I hope you get familiar with how we use the shift register in this kind of looping iteration.